Let's look at this question from a quant interview. You have a cup A with a volume of 1 liter. Each time you pour a random amount of water between 0 and 1 liter into the cup, and you repeat this process twice. What is the probability that the cup is not full after both pours? Let's first define the variables. Let the amount of water added the first time be x, and the second time be y. Since the condition is that the cup is not full after 2 pours, we know that x plus y is less than 1. We can solve this problem geometrically by drawing two number lines representing the two variables, x and y. Given the initial condition, we subtract x from both sides and get y is less than 1 minus x. Hence, the boundary is simply the line y equals 1 minus x, and the probability is the area under this line. Using the area formula of a triangle, which is 1/2 times the base times the height, we find that the probability equals 1/2. Now, let's consider a more challenging question. What is the probability that the cup is not full after n pours? This might seem a little tricky, so let's first look at a simpler case. For example, when n equals 3. Again, we can use the geometric method, drawing three number lines, x, y, and z, representing the volumes of the three pours. The condition is similar to before, but with an extra variable. So the sum x plus y plus z is less than 1. To graph this condition, we can first set z to equal 0, so we only have two variables to deal with. With z equals 0, we are left with x plus y less than 1, which is exactly the same line as we drew earlier. Next, we set y equal to 0, giving us x plus z less than 1. This line is similar to the previous one, but lies on the xz plane. Lastly, setting x equal to 0 gives us y plus z is less than 1, and this line lies on the yz plane. By plotting these conditions, we form a triangular pyramid, and the probability is the volume of this pyramid. Recalling the formula of the volume of a pyramid, which is 1/3 times the base times the height, we can calculate the probability to be 1/3 times 1/2 times 1, which gives 1/6. Do you see the pattern? When n equals 2, the probability is the area of a triangle, and when n equals 3, the probability is the volume of a triangular pyramid. So for any n, the probability is the volume of an n-dimensional simplex, where a simplex refers to an n-dimensional shape with n plus 1 vertices. For example, a triangle is 2-dimensional and has 3 vertices, while a triangular pyramid is 3-dimensional and has 4 vertices. Although plotting this case geometrically becomes too complex for larger n, we can still calculate the volume using matrices. We represent the shape by an n by n matrix, where each column represents the coordinates of a vertex. The volume of this shape is 1/n factorial times the absolute value of the determinant of this matrix. Next, we need to find the vertices of the shape. From the question, we know that the sum of the variables a, b, c all the way to n is less than 1, where each letter represents one pour into the cup. By setting b through n equal to 0, we get a is less than 1, and repeating this procedure for each variable, we get b is less than 1, c is less than 1, and so on up to n is less than 1. And note that here the lowercase n represents the uppercase n plus 1, since they are n plus 1 vertices. These conditions allow us to calculate the vertices as they represent the maximum values for each variable. The first vertex occurs when all other variables are 0 and the first is 1, so it can be represented by 1 followed by n minus 1 zeros. The second vertex occurs when the second variable is 1 and all others are 0. By collecting all these values, we form the matrix S. The determinant of this matrix is straightforward, as it contains many zeros. We only need to consider the diagonal values, which equal 1 raised to the power of n. Substituting this into the simplex volume formula, we find the volume to be 1/n factorial. Thank you for watching this video. This question unexpectedly connects probability with the volume of simplexes, which I find interesting enough to make a video about. If you also find these questions intriguing, please leave a comment below.